we're going to take a look at the converse of the Pythagorean theorem. Now, we've played with the Pythagorean theorem. You've played with the Pythagorean theorem. Nothing is new here. So we got the a squared plus b squared is equal to c squared. It's now that we are going to use this to answer a few other questions. So, to start with, I want to write the value of x in a simplified radical form. When we are going through and doing higher levels of mathematics, especially trigonometry, we want to have things written in an exact way. That's why we call this thing, we use the simplified radical form. So, here we go. We know that this is going to be a, that could be a b, and that has to be c, right? Two legs always make up the right angle. So that means that I have 5 squared plus 5 squared is equal to x squared. 25 plus 25 is equal to x squared. So that means that I have 50 is equal to x squared. Now, we need to identify whether or not 50 has any factors that are perfect squares. So the process that we can go through and do for that, or one of them is, what I tend to start with is I'll write down the number, and then I'll start with 1. Does 1 go into 50? Of course 1 goes into 50. I get 50. Does 2 go into 50? And I end up with what? 25. Does 3 go into it? No. 4? No. 5 does. And I get 10. 6 doesn't. 7 doesn't. 8 doesn't. 9 doesn't. And 10 is already there. So I have all of the possible factors. So are any of these factors perfect squares? And the answer would be yes, because I've got 25 as a perfect square. So what we're going to do, the square root of 50 is going to be the square root of 25 times 2, square root of 25, square root of 2. What's the square root of 25? 5. Square root 2 is equal to x. So if you need to write something in simplified radical form, this is the process that you need to go through. And the more you do with this, the easier at it you will become. But trust me, you will end up having to go through and doing this quite a bit as you move through your mathematical career. So, let's try this one. So I'm going to say that this one is, oh, I can't say that one's A, can I? That's got to be what? C. And this can be A, that can be B. So we end up with x squared plus 6 squared is equal to 5 square root 13 squared. So x squared plus 36 is equal to what? Well, what does it mean to be squared again? Does it mean you multiply two things together that are exactly the same? No, 6 times 6 got me to 36. So that means I should have 5 square root 13. 5 square root 13. Right? Well, what's 5 times 5? What's square root of 13 times the square root of 13? Good question for you. Do square roots undo squares? What's the square root of 4? What's 2 squared? What's the square root of 9? What's 3 squared? So square roots undo squares, right? Or squares undo square roots, depending upon your perspective. So, we said that the square root of 9 was 3. So if I take the square root of 9 times the square root of 9, what should I get? 9. So if I got the square root of 13 times the square root of 13, guess what I get? 13. So it turns out to be 25 times 13. So if it's 25 times 13, that means it's got to be 325, right? No, don't worry. It's not as amazing as you think it is, because I did this last night. What's 1 time, or what's 10 times 25? 250. 3 times 25 is 75. What's 250 plus 75? 320. Now I have to subtract 36 to both sides, subtract 36, and I end up with x squared is equal to, now I'll break out the calculator because I really don't want to mess that up. That out, 325 minus 36, and I end up with 289. Now, there are going to be times where you're going to look at this and say, I have no idea. It doesn't matter. Pop it into the calculator and see what you get. So I want the square root of 289. Oh, 17. I got lucky. Okay? This time it worked out. So always go through and check it just to make sure that it is actually going to be there. Okay? So, let's try this idea. I'm going to give you a few moments here, and I want you to copy this one down to make sure that you have it in your little. So the Pythagorean theorem itself says, if you have a right triangle, then a squared plus b squared is equal to c squared. So this is going back the other way. If I get a squared plus b squared is equal to c squared, hey, guess what? I got a triangle. That is right. So, here we go. Is this going to be a right triangle? I don't know. I say it is. Now, well, can I just look at it to determine whether or not? Okay, if it had one of those thingies drawn in there, then that would tell me precisely that it is a right triangle, but I don't have that information. All I am told is that a squared plus b squared is equal to c squared. So, we're going to kind of go through paragraph proof and talk this thing out a little bit. So, I am going to go and write it out like this. I am going to say that triangle PQR is right. Well, it is right triangle besides A, B, and X. So, I want to make this triangle. And I'm going to make the triangle here so that I have P, Q, and R. I am going to say that A is going to be here, B is going to be here, and X is going to be there. So that means that A squared plus B squared is equal to X squared. Do you agree with that statement? Okay. Do you agree that I can make that statement? Okay. I just used two of the sides that were on there, the A and the B. And I said, hey, this thing here is now a right triangle. So, since I used A here and I used A here, does that mean that TU is congruent to, say, PR? Would you agree with that statement? Would you also then agree that, let's see, SU is congruent to QR? Would you agree with that? Yes, sir. Oh, gosh. Doesn't work that way. And I could show you why it is, but I'll do that if I got time at the end of class for it. So just hold that thought for a minute. I want to kind of finish where I'm at. Okay? So, what ends up happening here is, as I said, those two are the same, right? So I've got that side congruent to this side. I've got that side congruent to that side. Do you see an X the exact same thing? Is there any way that I could say that C squared is equal to X squared? Could I do it this way? Is there anything that tells me what C squared is equal to? And I have that right here. They tell us that A squared plus B squared is equal to C squared. I just made another triangle with sides A squared and B squared down here. So, because I've been given that information, I know that that's going to be the same. And then I can go through and say that TS is congruent to PQ. Would that make sense? Because if those are the same and they equal X squared, then that means C squared has got to be the same as X squared, which implies that, TS has got to be the same as PQ. So, by side, 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 we know that we can use, if three sides of a triangle are the same to three sides of the other triangle, we know the triangles are congruent, right? So that means that triangle STU is congruent to triangle PQR. So triangle STU is a right triangle. Now you're looking at that obviously and saying, well, no. But remember what we said about figures earlier on. Figures lie. Correct? That's what we have to keep in mind. So, by the rules, I know that this has to be a right triangle. Even though it was drawn poorly, I still know that it's a right triangle. This here. Okay. Yeah, the reason why I say that is because the A here is the same as the A over here, right? This A is the same as that A. Because it's A. See, if we go through and use something with the same name, or the same label, we are saying that it's the same thing. But if you remember correctly at the beginning of the year, we talked about measuring doesn't prove anything. It demonstrates it, it shows us, but it doesn't prove anything. Okay? We cannot measure so exactly that it is going to be proof. We can go and say that things are the same. Okay? Do I actually need to know how long A is? Do I? It's an honest question. Do I need to know how long A actually is? No. And you are correct. I would agree with that. As long as I know that this A is the same as this A, okay? And this B is the same as this B. it's the same idea when you go out and buy yourself a bag of Doritos. Do all of the bags of Doritos have exactly the same Doritos in them? No, because they're different. Doritos are different, right? I know, it sounds like an experiment that we should check out. Right? A whole bunch of bags of Doritos. Okay. And there is a reason why that they do that. That's again another discussion for a later date. But do I have the same amount of chips in each one? Am I supposed to have the same amount of weight in each one? And that's the yes. Now, obviously, there is no way that they're going to weigh each and every chip and put it in there. Actually, what they do is they weigh a bunch of them, and they have electronic scales that are set up so that a whole bunch of chips are in, so that they know which bins they could drop into it to make up a certain amount. It works. It's approximate. But if I say that they are the same then, correct? And we assume them to be true. So, a bag of Doritos is a bag of Doritos is a bag of Doritos. So, I want to determine whether or not this is the right triangle. Well, if it's a right triangle, could this be A and could this be B? And then this should be C, correct? So that means I'd have 4 squared plus 11 squared is equal to 12 squared. So 4 squared is 16. That's 121. This is 144. I add those together and I get 137 is equal to 144. Is this true? No. Now, this looks like it could be a right triangle, right? Yeah. Just because they have a 4, 12, and 11 there doesn't mean that the lengths of those sides are actually 4, 12, and 11. Remember, we said pictures lie. Images lie. We can only go by what the labels are and the rules that we are given. So, is this a right triangle? Well, it says it's not a right triangle, but we'll see. So let's see, this should be A, that should be B, and that should be C, yes? So that means that I have 5 squared plus 12 squared is equal to 13 squared. So that's 25 plus 144 is equal to, I think 13 squared is 169. Last I checked. Well, what's 25 plus 144? 169 is equal to 169. So it is a right triangle. Okay? Again, just because the picture looked like it doesn't mean that it is. We need to verify. So, give you a few moments, and I'll let you get this one. All right. So, what happens if we use the Pythagorean theorem and it comes out that it is not equal? Is it completely useless for us? And the answer is no. Obtuse means bigger than, right? Big A. So if I do this and it turns out that C squared is larger than A squared plus B squared, bigger, obtuse. You've got an obtuse triangle. I know that. If I have A squared plus B squared and it turns out to be smaller, did I say bigger? I said that the wrong way around. A squared plus B squared has to be smaller than C squared for it to be an obtuse. C squared has to be bigger. And if C squared is smaller than A squared plus B squared, then it is a cube. So, let's give this a try. I want to know what kind of a triangle this is. So, the two smaller sides appear to be 4 and 8. So I'm going to call that A, I'm going to call that B, and I'm going to call that C. Because if it was a right triangle, the two smaller sides make up the right angle. Yes or no? So that means I have 4 squared plus 8 squared is equal to 9 squared. Well, I don't know what's equal to 9 squared, so I'm just going to put 9 squared there. So that's going to be 16 plus 64, and this is 81. 16 and 64 is 80. This is 81, so that means it is less than. So, what kind of a triangle do I have? Obtuse, acute, or right? I have obtuse. Why? Because c squared is larger than the a plus b. Kind of easy, right? Makes sense, though? So, let's try this one. See how this one turns out. Again, the two smaller sides should be a and b, and that's got to be c. Well, they say that this one's obtuse. If it's less than, is it less than? No. So we've got 5 squared plus 6 squared and 7 squared. 35 plus 64 and 49. Do I even need to go any further to figure out that this has got to be greater than? No, because I know 64 is already. Well, hold a second. How can I get 64? That should be 36, sorry. That shouldn't be 35. That should be 25. Ooh, brain is definitely off for one there, right? Well, still, even 25 and 30, you know, is going to get you more than 49. Okay, still. So, this has to be what type of triangle? Acute. Okay. Let's try this. It says a local library needs a ramp for wheelchair access. The city says that the ramp should be built with a slope of 1/4 and must reach a platform that is 2 yards high. What must the length of the ramp be? Okay. Well, when they give you that slope, remember slope is rise over run. So I have 1/4, and they tell me that it's got to be 2 here, so what number goes down there? 8, most definitely. Yes. Okay. So we know that this has to be 8. Well, that means that I end up having 8 squared plus 2 squared is equal to y squared. So that'll be 64 plus 4 is equal to y squared. So I got 68 is equal to y squared. So I got to find the square root of 68 is equal to y. Yes? Now, if I actually would go through and read the instructions, do I have to write this as in simplified radical form? No, it says round to the nearest hundredth. So I'm going to take my calculator and take square root of 68, and I end up with 8.25 is equal to 1. So that means that the ramp length would have to be 8.25 yards. Biggest thing that you can do is fill in the information that you know and see what you can see. So, what I want you to do is I'm going to give you a couple minutes here, and I want you to do this one. All right, let's see if you agree with me. So if I go and say I've got a squared plus 20 squared is equal to 27 squared. Yes? So that means that I've got a squared plus 400 is equal to, I have no idea what 27 squared is, so I take 27 squared, and I end up with 729. Subtract off 400, subtract off 400, and I end up with a squared is equal to 329. So a has to be equal to the square root of 329. Now, I got to try and figure out whether or not 329 has any factors that are perfect squares. Well, let's go. We got 329 1 and 329. Does 2 go into it? 3? No, because if I add up the digits, I don't get something that's divisible by 3. Little trick. Well, if 2 doesn't go into it, that means all even numbers don't go into it. So that 5, that doesn't end in 5. Is this thing divisible by 7? First one I got to check. 329 divided by 7, and I end up with 47. 7 and 47. Does anything go into 47? Oh no, 47 actually turns out to be a prime number. So what this means is that that's as simple as it can get. And sometimes this is going to happen. That A is equal to the square root of 329, so you get this. So, give this one a whirl. See what you can come up with. Alright. So, let's see if this is the right triangle. If this is the right triangle, then the two smaller sides should be A and B, and the larger side should be C. So that means that 8 squared plus 14 squared should be equal to 15 squared. 8 squared is 64, 14 squared, well, we'll just go over here, 14 and square it. And I end up with plus 196 is equal to 15 squared, which should be 225. And if I go and take 196 plus 64, I end up with 260. Is 260 equal to 225? No. So is this a right triangle? No. But now you've got the work that you see that you have to do in order to verify. So, I'll give you a minute or so and let you figure this one out. Alright, let's see how this one turns out. Now, we know the two smaller sides are supposed to be A and B, so I'm going to call that one A, call that one B, and call that one C. Now, since we're trying to determine whether it's acute, obtuse, or right, what I want to do is take A squared plus B squared and then compare it to C squared. So that'll be 7 squared plus 8 squared, and I have 13 squared. Well, this will be 49 plus 64, and 49 plus 64 turns out to be what? 113. So I'm going to take 13 and square it. Oh, that's at 169 again. So that means that 113 has to be less than this. So does that mean it's an obtuse triangle? Now again, I know it looks like it should be an obtuse triangle, but we do not want to go and state it that way. Okay? This verifies. So, give you a few moments, and I want you to give this one a try. All right, here we go. So again, we need to take the two smaller sides. So that's got to be A, that's got to be B, and that's got to be C. So I get 7 squared plus 24 squared, and I want to compare that to 25 squared. Well, 7 squared is 49. Let's see, 24 squared gives me 576. And 25 squared gives me 625. So it looks as though that if I go and take 49 plus 576, I end up getting 625 is equal to 625. So that means it must be a right triangle. There you go. So, give you a few moments, and I want you to go and think about this one. See what you can come up with. Alright. So it says a ladder leans against the wall. Its top reaches to a window that is 6 feet above the ground. Bottom of the ladder is 7.5 feet from the base. Now they don't have that in the picture, so I want to make sure that I put that in. So from here to here has to be 7.5. Okay. Now, do the ladder, the wall, and the ground form a right triangle? Now, you would love to go through and say, well, yeah, nobody builds a wall to the ground that's not at a right angle, right? But what happens if it's placed, if the house is on a hill and it's an embankment? So, I mean, there is that possibility. So this means that I should take 6 squared plus 7.5 squared and compare it to 10 squared, correct? Oh, we know that's 100. 36 plus 7.5 squared, and I end up with 56.25. So if I add 36 to that, I end up with 92.25. And this is 100. So that's less than it, correct? So, does it form a right angle? The answer would be no, it does not. Why? Because we know that a squared and b squared are less than 10 squared, so it's not a right triangle. Therefore, it cannot be a right angle. Might be really close, but no. There you go.